Okay, last one, research methods task 4. I'm smiling because this is my fourth attempt at trying to record this one. I think I've been doing this for far too long today. My head's starting to spin a bit. Must need to watch some football. So here we go. Let's get it right this time. So this is what we're looking at. Descriptive statistics, things that we've mentioned already. Measures of central tendency, measures of dispersion, and a brief look at graphs as well. So yeah, descriptive statistics describe your data set. They provide the sort of headline figures. Back in the days of coursework, when I first started teaching psychology, sometimes students would hand in their work and you'd get through the method, and then you get to the results and you have all these weird pages and pages of tables with numbers in them, and they'd included their raw data in their main report. You don't do that. You provide descriptive statistics, you summarize it, so you've got a clear snapshot of the main findings. It tends to be two things that are reported: measures of central tendency, measures of dispersion. So yeah, measures of central tendency, the central value, the most typical value. I'm sure you've all calculated the mean many times before, add them all together, divided by a number of items. Please just think, does your figure look feasibly correct? I had somebody once before multiplied them all. It came up with some horrific figure and couldn't understand why I was laughing at it. So please think, does it look feasible? Just be careful, don't rush because you think it's easy. Median, that's where if you list all the values from lowest to highest, it's the central value. If there's two central values and you add them together, divide by 2, and mode is the most frequently occurring value. Now the main problem, which drives me mad in exams, is that students don't realise what measures of central tendency means, what it's referring to. If a question said, oh, tell us if they should use the mean, median and mode, that'd be fine. But it says state a suitable measure of central tendency that they could have used and explain why it's appropriate. And sometimes students think, what's that? Okay, very annoying. So measures of central tendency, without hesitation, mean, median, mode. Now, they do have the pros and cons that you need to be aware of. The mean is the most representative because it's calculated using all of the values, whereas the median is less representative because you're just looking at the central value. So, as with many things, as we've said before, in research methods, the strength of one is the limitation of the other. Now, a crucial thing for you to look out for is outlying scores or extreme values. Individual values that are out of keeping with the rest of the data set. Now, if you're looking at a table of scores in an exam, just think, is there a value that's really out of keeping with the rest? Have you got increments of two or three between the others and then 20 with another one? If that is the case, if you're thinking, yeah, actually there is an outline score, you don't use the mean because it is more affected by it. If you've got a much higher score from one person than everybody else, their score, because it's included in the calculation, will drag up the mean. The mean will be artificially high. Whereas with the median, that score will be discounted straight away because you're counting in towards the central value. So if there's an extreme value, you go for the median. Okay, so please just check the data carefully. If you're thinking, no, actually there's not, there may well not be. If there's not, then use the mean, fine. If you've got any doubt, if you're thinking, oh, that one's a bit out of keeping with the rest, then you go for the median. The mode doesn't crop up as often, should be obvious when you need to use the mode. It's not affected by the extreme scores, but the downside of this one is you can end up with more than one value. So if people are voting for different things, you might have 3 things that had 6 people vote for them, so you end up with 3 scores. So that's the downside. If in that situation, it's not much use. So that tells you about the middle of the data set, but then you want to know a little bit about the rest of the data, the spread of the data. So there's 2 measures of dispersion. So if you see measures of dispersion, you think range and standard deviation. Range is the difference between the highest and lowest values, very easy to calculate, we'll come to that in a bit. Standard deviation, much more complicated to calculate. You don't have to know how it's calculated for psychology. If you know this from somewhere else, then so be it, fine. But you're not going to use it. You're not going to be asked how it's calculated. You're certainly not going to be asked to do the calculation in an exam. Range you could be asked, but that's not hard. So yeah, the standard deviations, the one that's used the most, is the measure of variance telling us how far the scores deviate from the mean. And the absolute key thing for you to bear in mind, the higher standard deviation score, the greater the variance, or the less consistency there was in the score. Okay, so the flip side of that, the lower the standard deviation, the less variance there was in the scores, or the more consistent the scores were between participants. I don't know if this will help or hinder, but if you look at where you've got a standard deviation of 0.5, if 0 is the mean, then those scores are all quite tightly grouped around the mean. As the standard deviation gets higher, then the scores are more spread out. That's what we're getting at. But don't let any of this put you off. Just remember, standard deviation, you write the words. The higher the standard deviation, the greater the variance in that group. So again, with these, you need to know the pros and cons. The range is very easy to calculate. I know in some resources they talk about the adding 1. I haven't done that, but I've seen it. I think it's even in the resource we're using. From an exam board point of view, it seems as if either's fine. I've always gone with just the difference between the highest and lowest value, and it's been fine, so I would go with that. But if that's going to confuse you because other teachers do other things in other subjects, then sometimes they do add 1. I think it's to allow for where numbers might have been rounded. It's not worth worrying about. So I would say for the range, just calculate the difference between highest and lowest. So that means, yes, it's easy to calculate, but it is definitely distorted by extreme values. If I had class scores of where most people got 20 out of 50, but one person got 50, then I'd end up with a very high range. Oh yeah, real range of scores, real range of ability in this class. When actually, no, there's not. Apart from one student who's head and shoulders above everybody else, there's actually quite consistent ability. So that's affected. That's the trouble with the range. Very much affected by extreme or outlying values, and yes, doesn't tell you anything about the pattern of distribution across the data set. It's a very blunt tool. Oh yeah, big range, but it doesn't tell you about what's going on within that. So that's why we use a standard deviation much more often in psychological research, much more precise. It's calculated using all of the scores. It's not as affected by extreme values, but again, you've got the flip side, which is it is more difficult to calculate. But yeah, most of the time, it's a standard deviation. People tend to default to mean and range on these things. If anything, it's a safer bet to default to median and standard deviation. If you're really not sure, they're probably the safer bet if it comes to it. But hopefully you'll be able to justify it anyway. Now I'm showing you this common scenario here where you're given a table and it will have a mean and it will have a standard deviation. Now I'll need my glasses for this. Right. So yeah, we've got condition 1, recalling words in the same room that they've been learnt, and then condition 2, recalling words in a different room. And what does the mean tell us? Well, looking at this, the mean would say that there was a higher level of accurate recall in condition 1. So as we might expect from the stuff we've covered in the memory topic, recall was best when it took place in the same room as the original learning, because it's got a higher mean. It's got 15.9 compared to 10.6. If you're writing an answer to this, do make sure you do what I've done. Don't just give the table, don't just give the figures, you have to explain it. Okay, so what does the mean tell you? Sometimes I get an answer that says the mean tells us that in condition 1 it's 15.9, whereas in condition 2 it was 10.6. Well, thank you very much for that. It hasn't told me anything. So the mean tells us that recall is best when it's under the same conditions as it is learned, because the mean for those in the same room was 15.9, which is much higher than 10.6. Okay, so I hope you can see the difference between those two examples there. However, you will be given a standard deviation as well, and I see this combination quite a bit. So you've got a higher mean for one condition, but you've also got a higher standard deviation for that condition, quite a considerably higher standard deviation here compared to the condition 2, 3.78 compared to 1.04. So what we're saying here, what this means is, as we said, the higher the standard deviation, the greater the variance in the score. So we're saying on average, recall was much better when it took place in the same conditions as the learning. However, there was greater variance between participants. So in everyday language, that's saying that yes, while it helps a lot for some people, it didn't so much for others. Whereas when it was in a different room, the scores were much more consistent. So that's what this is asking you to say. So watch out for this. It'd be so condition 1 did best because of the higher mean, but it wasn't as consistent. The scores weren't as consistent, so there was greater variance in that group as well. Different scenario, it could be looking at 2 potential drug therapies or 2 therapies. Now it might be that maybe you wouldn't have such a big difference if the mean was slightly higher for one drug, but then the standard deviation was quite a bit higher as well. Then that's a bit of an issue, because you're saying, well, yeah, that on average that drug was a bit more effective, but actually the standard deviation means that there's less consistency. So there could be a case argued for the other drug, even though it's a fraction less effective on average, it gave more consistent results. Okay, so just something to watch out for, but don't lose sight of the basic point. The higher the standard deviation score, the greater the variance. Just get that in your heads. Okay. Now I said reading for this because it doesn't come into the questions, and also if we've done it, this isn't difficult. So tables, we've all drawn many a table before, showing the data. Just the key thing with all this is labelling. Remember your labels. Now you've got no excuse for this. I've been supporting my 8-year-old son with his year 3 maths, and that involved tables and graphs and drawing the graphs and remembering to label the axes and all of that. So I'm pretty sure A-level students should be able to do it. So remember, sometimes there's 4 marks available, 3 of which are for the title and labelling the 2 axes, and 1 mark for what goes in between. Okay, so please just remember that. So tables, give it a sensible heading. Scattergrams, scattergraphs, we did that in the previous one for correlations. And then bar charts, that's for discrete data, it's called. We're going to do this a bit more next year, but discrete data where it's in categories, so the bars aren't touching, as you'll see on the example there, different groups. Whereas a histogram, the bars are touching because it's continuous data on a scale. Okay, so have a read through that in the book, but there aren't any questions on this one. And that's all I want to do for this one. We will be giving all of the mathematical stuff a big push next year.